Welcome back, Algebra 2.2. What we're going to be doing today is we're going to go through bell work, the homework quiz, proportions, and rational equations. So if you have yet to watch that video on that lesson, go back to the previous day's video, day 11, for proportions and rational equations. Watch that video and then come back to this video so you can take the homework quiz. We're going to go through the objective, essential question, and then we are going to be learning about rate of change and how it relates to graphing some basic functions that hopefully we should already know how to graph. So most of this lesson will probably be review, but there's some nuggets of Algebra 2.1 stuff in there. So some Algebra 1, but some nuggets of Algebra 2.1. Let's go through bell work. This is just questions taken directly from your homework quiz for proportions and rational equations. So if you're paying attention here, then you should be adequately prepared, at least for 2 questions for your homework quiz. Let's get started. First off, is this a rational equation or is this a proportion? Well, this is an equation. Sure, it's not a proportion. Proportions are like this. If I have x all over 7 and it equals like x all over 8, when I have one fraction equaling another fraction, notice how this is not that. This is not a proportion because I have this 1 and negative just chilling out here. So it's definitely different. So notice that. Okay. With this, you can just multiply, and this is 8x equals 7x, and then this is x equals 0. That's really what it is. It's very simple. Okay, but that's not what we have here. That's a proportion. What we have here is what we call a fractional equation. Why is it not a rational equation? A rational means fraction, sure, but a rational equation is when you have an x in the denominator. So right here, a rational equation is this x in the denominator, that x in the denominator. This is a rational equation. This is what we just call a fractional equation, where we have a fraction but no x in the denominator. So since we don't have an x in the denominator, are there any exclusions that we need to kind of take out and say, hey, the denominator can't be this? Well, no, because you can have a denominator of 3, you can have a denominator of 1, you can have a denominator of 8. It doesn't matter. It's only with rational equations in which you have to find an exclusion. And normally that exclusion, if you remember from the previous video, normally that exclusion is 0. So let's get to it. What is my LCD here? My LCD should be 24. Okay. Again, if you don't know, you can just multiply 3 times 1 times 8. Just multiply them all together, and then you get 24. You multiply them all across. Okay. So then that means I'm going to take 24 divided by 3. 24 divided by 3 is 8, so I have 8 times x plus 2. Now notice my use of parentheses. 24 times 1 is 24, and then 24 times this is a negative, watch my parentheses here, okay, a negative 24 divided by 8 is 3, so I'm going to take a 3 here and then put my parentheses there. Make sure you tag on that negative so you don't forget it, okay? Let's distribute. So this is 8x plus 16 equals 24. This is minus 3x minus 18. We can combine some stuff here. I'm going to just drop this down. This is going to be negative 3x, and this is going to be plus 6. So let's add the 3x over here, subtract the 16, and then bring it up here. Add the 3x over, so that means I get 11x. Subtract the 16 over, I actually get 6 minus 16, which gives me 6 minus 16 is going to be negative 10. We continue just by dividing 11, and so what is my answer? Negative 10 all over 11. It's okay if you get a fraction. It's fine. Okay? Totally cool. Right? And if you want to check your answer, you can plug it in there, but I'm not going to because that is nasty. Okay, let's go to this next one. I need to multiply by my LCD. What's my LCD here? My LCD is actually 8x. Okay, 8x all over 1 because everything goes into 8x, right? 4x goes into 8x, x goes into 8x, 8 divided goes into 8x, and so now it will eliminate all my fractions, my denominators. So I multiply through all of that, multiply through. X's go poofy here. 8 times 3 is 24. 8x times 3 is 24x. Notice how I don't have any fractions. That's what I want. 8x times this, well, 8x divided by 4x is just 2. The x's go poofy, and 8 divided by 4 is 2. So 2 times 3 is 6. And then 8x times this, well, the 8's go poofy, so I'm just left with plus 25x. Now, I kind of went through that pretty quickly. So replay the video. Replay the video and just kind of, I want you guys to see how I actually do it and how I actually show you, like how I talk through the math, as it were. Okay, I'm going to start combining things. That means I'm going to subtract that over here, subtract that over here. So this is actually 18, and this will be x. So that is my final answer. Now my exclusions. When they ask for an exclusions, my exclusions is, of course, x cannot be 0, because if I put 0 in for x here, that would be 4 times 0. 4 times 0 is 0. You can't have that because you can't divide something by nothing. Same thing here. So my exclusion is 0, and of course that's not 0. 18 is not 0, so that is my final answer. I don't need to do anything more. Okay? Again, I went through those pretty fast. If you feel like you need adequate time, more practice, go through the homework on Math Excel, the proportions and rational equations. Go work a couple more problems like that. Go to the study plan on Math Excel. Go through that. Go through my video from the last video, or just replay this little segment. Okay, I went through it fast because, again, I don't want these videos to take any more than usually an hour, and so I know sometimes they do go past an hour, but I want to be cognizant of that. I try to explain everything to the best of my ability and then go further into it. Okay? So let's erase and let's get you started on the homework quiz. So the homework quiz, proportions and rational equations, 5 questions, 25 minutes, of course open notes. When you're finished, you can begin your Cornell Notes rate of change and graphing functions. Now, important announcement, today marks the beginning of week 3, which means if you have yet to get an A in my class, that means, yes, you are required to do this homework quiz. But if you are so fortunate enough to earn an A these last 2 weeks, and you have a current A right now before you take this homework quiz in the gradebook, in Synergy, then no, you don't have to take the quiz. Okay, I will definitely excuse it for you. I grade every morning, and so that is a blessing to you. You don't have to take this quiz. Can you? Yes, if you want, but if you fail it, will I put it in? No. Okay, I will not put it in. If you do amazing on it, will I put it in? Yes. If you get 100 on this quiz, even though you don't have to take the quiz, then yes, I will definitely put it in because that will help you. Okay, so feel free to utilize that. But if you do not have an 89.5% or above in my class, you do have to take this homework quiz. All right, so pause the video if you want right now, get started on the homework quiz, and then come back so we can get started on the notes. Rate of change and graphing functions. Okay. I love this meme. This is so hilarious. Okay, he buys an expensive graphing calculator and finds a free online graphing calculator website. Say goodbye to the TI-84s. I don't know why the school continues to buy them, to be honest, because, I mean, let's be real. We have Desmos, right? So, since we have Desmos, we might as well just use Desmos. I don't get it. Now, this is free online graphing calculator. I obviously use it a lot. I thought that was hilarious. We are going to be graphing some functions, but not a lot. I'm going to show you how to do it by hand, of course, because a lot of it is review. Now, we're going to analyze what we call the rate of change by translating the data of changes from a table to the graph. So I'm going to show you what that looks like. And then I'm also going to ask, how are slope and the average rate of change of a function related to each other? And how do I graph a basic linear / absolute value function? Okay, I'm going to show you that. So again, a lot of this, the graphing portion will probably be review, but I think it's good review. So let's review slope of a linear equation. Slope of linear equations. So let's think back, okay, to one lesson in particular last week, the functions lesson. Think back to the linear function we created last week with the arithmetic sequence. Our arithmetic sequence is 1, 4, 7, 10. Okay? All right. And then I want you to plot the points and connect a straight line. So if you recall, my points were 1, 1, 2, 4, 3, 7, and then I'm going to just stop here, 4, 10. So these are the beginnings of my points in fancy braces. These are the beginnings of my points. So we're going to try to plot this again and go from there. So 1, 1 is right here. Perfect. 2, 4. 2, 4 is right here. 3, 7 is right here. And then 4, 10. Let's try to get a perfect line. And I think I can get a perfect line using this little function right here. Watch. Hopefully I can get a perfect line. Oh, look at that. That is a perfect line. Only I wish it was pink, right? That would be even better. That would be perfect. Oh shoot, what did I do? Okay. That is a perfect line. Make sure you have that down. Okay, so now what we're going to be doing is this. Write the equation, the function for it. Now, of course, if you remember, our function for it was really simple. Okay, it was y equals 3x minus 2. In fact, we actually use function notation. We use f of x equals 3x minus 2. Now, let's just say we didn't know that. Let's just say we didn't have our notes with us and we couldn't just recall our notes. How can I find it? Well, I can use slope, right? I can find 1, 2, 3 all over 1. So I know my slope is 3. My y-intercept, I mean, it looks very clear to me. I mean, that's perfect, right? My y-intercept is right here, -2. Okay? So if that is my y-intercept, that's my slope, I have y equals 3x minus 2. And that's exactly what we got here. Wow, that's a 2. Jeez. Okay, so yes, we already should know this. This is Algebra 1 review, and so I'm not going to spend any more time on this than needed, but that's really what we're talking about. So what is the slope of this linear equation? I already said the slope is 3. And then we can continue on and say the b value is -2. Okay, and that is my function. So this is how we do slopes. I just want to review this. This is nothing new, but I'm going to kind of put some more math to it. So let's erase all this junk. Erase all this junk. And let's now continue. I'm going to show you this. This is really what's happening here. So this is the formal review for Algebra 1. What is the slope between 2 points? The slope is what we call a change in y all over change of x. So the change in the vertical portion of the graph all over the change in the horizontal portion of the graph. So that's what we say. Rise, we kind of do this like tongue-in-cheek. It's rise all over run, or what we say vertical change all over horizontal change. What do I mean by change? It means the graph shifts. The graph shifts different ways. And that's what I'm going to show you a little bit today. Not a lot today, but a little bit today. And we're going to go more in it with the Desmos activity later this week. But it does shift. And so this kind of gives us our amazing formula right here. Okay, now, of course, this denominator right here cannot be 0, or otherwise the world would explode, right? But what this does give us is an amazing formula that we've been using for years and years and years, all the way since Algebra 1. But some of you actually took Algebra 1 way back in 8th, 7th grade, 8th grade, 7th grade, or maybe even 9th grade. And now you're juniors or seniors, and so you should remember this if your teacher taught it well. If I was your teacher, then I hope you remember it. Okay? What does that look like graphically? Graphically, it looks like this. So this, the y, y2, y1, notice how this is the rise, this is the change. This is the vertical change, or the change in y. And this right here, the run, the horizontal, and this is the vertical, the horizontal is that. So it's the change in the horizontal part, x2 minus x1. What's interesting is it makes a nice little triangle, and of course, if you take trig with me, this becomes even more interesting when we start introducing triangles to the xy plane. My trig students are loving it, okay? But we don't need to know that right now. All we need to know is that's what it is, change in y over change of x. So if I go to this slide, we're going to review some slope. Now, if you feel confident in finding slope, by all means, don't waste your time here. Skip this. I'm going to review it because I think it's necessary to review it, just to make double sure that we know how to find slope. This is my formula, okay? And if let's just say I'm giving these 2 points. Now, how I'm going to find this is how I do it, and I find it just to be so beneficial. I actually stack them on top of each other, okay? The reason why I stack them on top of each other because it's very helpful for me. Now, it doesn't matter which y value here, 5 or 3, that's my y values, 5 or 3. Doesn't matter which one is y2 or y1. Actually doesn't, as long as you're consistent. So in other words, watch what I'm about to do here. Let's do it to actually red here. In other words, watch, okay? If I take 3 minus 5, okay, so boom, boom, I can do that, and that's why I have like boom, boom. Like I start at the bottom, like boom, boom, and I go divided by, and then boom, boom, 6 minus 4. So that's why I like stacking them. To me, I've been stacking slopes ever since I was like in Algebra 1, man. Way back in the day when I took Algebra 1 with my algebra teacher, I've been doing that for a long, long time. So what I'm saying is this helps me, and a lot of it, maybe some of it helps you, if just to kind of use those short little techniques there. So now I can simplify. 3 minus 5 is negative 2, and this becomes 2, so my slope is negative 1. Okay? Now let's kind of crank out the rest of these. I'm going to do these really fast. So this is 3 comma 1, and this is 3 comma 3. And remember, it doesn't matter which is your y2 or y1, x2, x1, as long as you're consistent. So boom, boom, 3 minus 1, and then your x's, boom, boom. So 3 minus 3. Now, of course, this becomes 2, but this becomes 0, so what the junk? This means undefined. I cannot divide something by nothing. I said that in the last video. So since I can't divide something by nothing, this becomes undefined, and this is also what we call a vertical line. Okay? This is also what we call a vertical line. Now, if I go to 3 here, let's do this. So 2, 8, and then all over 2, 8. They're the exact same point. So, I mean, what is this going to be? Like, this is no solution. What is this? So let's try it. Boom, boom. So this is actually 8 minus 8, and then boom, boom. So that is 2 minus 2. So this is 0 all over 0. What is this? This is still undefined, okay? Just like I said on the video yesterday. However, this is not a vertical line, okay? This is just no line. It's a single point on the graph. It doesn't have a line in it at all. In fact, what it means is you cannot find a slope if you don't first have 2 separate points. That's actually a definition in geometry, if you recall, maybe. You need to have 2 points in order to get a line, and in order to have a slope, you need to have a line. So since that we can't calculate the slope here because there's no line to calculate the slope, right? Because it's only the same point. So that's very interesting. Now let's go to my last one, 4. So this is going to be 5 and then 6, and this is 5 and then 7. So if I find my slope, boom, boom, so this is 7 minus 6, and then boom, boom. So this is 5 minus 5. Of course, what we get is the same exact thing that we got here. It is undefined with a vertical line, okay? So think about this. Think about this and the review that's happening here with Algebra 1. I'm going to erase. Let's continue. And let's get into more Algebra 2 stuff. So this is not Algebra 1. This is now we're going to see how what we just did, the slope of a function, what we just did is going to be different. What do I mean by different? It's going to be a little bit big boyish. Now, when I say average rate of change, I want you to be thinking one thing. Ready? When I say average rate of change, you need to be thinking, surprise, slope. Because it is slope. Now, you look at this graph and you're like, what the junk is that? Relax. Okay, first of all, look at this formula here. This formula is actually just your slope formula. If you don't believe me, okay, this is m equals y2 minus y1, and then all over x2 minus x1. And you're like, well, okay, Mr. Carlson, like the bottoms are the same, the denominators are the same, but the tops, like, get out of here. What did we say just a week ago? We said y equals f of x. They are the same thing. So if I have f of x sub 2 and then y sub 2, are they the same thing? The answer is yes, kids. They are the same thing. Okay, that's the purpose, that's the point. So when you see this is what we call the average rate of change formula, but guess what? It's also what we call the slope formula. It is the slope formula. And instead of just using linear lines in order to find the slope, what we're now going to be doing is Algebra 2 stuff. What we're now going to be doing is finding the slope of parabolas, of bigger functions, okay? So this is what we call the secant line, okay? So let's just say I'm given these 2 points. Now this function right here is actually a sine function. It's a weird sine function from geometry, trigonometry. Don't care about that though. We just say it's going to be a function. What I care about is looking at the points. Now let's just say I have this point and that point, okay, and this weird blue function, whatever. This line I'm highlighting in green here is what we call the secant line. Now if you remember in geometry, maybe you had a circle, okay, and you had a line that looked like this, and it touched the circle at that point, touched the circle at that point. What that means, guys, this is what we call a secant line, okay? Secant line literally just means to break. That's really kind of what secant means in Latin. It just means to break, okay? Okay, so before you freak out, I'm going to show you some certain problems that we're going to do using this formula. And then we're going to go back to this graph. So the first thing we're going to do is use the formula. And then second thing we're going to do is actually see how it affects this graph. What's actually happening here? Okay, why is this important and how does it connect to functions? Because that's our unit, right? Functions. So first thing, I'm going to show you an example of going through it. And then I'm going to show you, using that example, how it relates to graphing. Because that's also what today is about, right? Graphing. Okay, so pause the video if you need to. Write anything you need to get down. Let's get started on the example. Awesome. So this example right here, we have 3 actually. We're given one function. The function that we're given is f of x equals x squared. F of x equals x squared. So to your normal parabola, I mean really your normal parabola looks like this. If you guys don't remember, your parabola looks something like this, looks like a U. Okay? That's your parabola. Awesome. So now A, what will that look like? Well, first of all, what's my formula? My formula is this, f of x2 minus f of x1 all over x2 minus x1. Now remember what f of x means. It means function, and it means you're plugging something into a function. That's what you're doing. You're plugging something into a function and getting something out. Okay? So let's look at A. I'm given the x values. Now, you may be asking, what the junk? Where's my points? Where's my y values? I can't do slope without y values. Yes, you're right, you can't. So that means you need to plug the x into your function and evaluate your y's. So now notice in Algebra 1, they just gave you 2 points. What if you don't know the point? What if you only are given x values? Can you find the y value? Yeah. By using the average rate of change formula and plugging it into your formula. plug it into your equation. Okay, so what does this look like? Well, what this looks like is f of x2, well, f of x2 is 1. That's what I'm given. Minus, following my formula, f of x1, well, f of x, or x1 is 0, so I'm going to do 0. And then all over x sub 2, 1, minus x of 1, so 0. If I simplify this, now watch what I'm about to do here. I'm going to actually put this in brackets because f of 1, what that means is you're going to plug 1 in for x into your equation. 1 in for x. So what is really 1 squared? And that's what we're asking. Now notice I'm putting in brackets, parentheses, because I'm trying to separate this f of 1 from this f of 0. Okay, I want to separate those. All right, so since I want to separate them, I'm going to do the exact same thing, minus, because that's what my formula says, like, right? Yeah. And then I want to plug in 0 in for my formula. So instead of 1, I'm going to plug in 0, 0. So that means brackets 0 squared. And of course, 0 squared is just, 0. And this is all over. 1 minus 0 is 1. So this equals 1 squared is 1 minus 0 squared is just 0. And this is all 1. So it is 1. What does that mean? It means my average rate of change is freaking 1. That's what it means. Okay, what does that mean? It means your slope is 1. That's what it means. Okay, now what is B? Okay, B, if I do f of x of 2, which is 2, and then minus f of 1, because that's x of 1, and then this will all be over x of 2, which is 2, x of 1, which is minus 1. What is f of 2? F of 2. F of 2 is just plugging it in. So f of 2 is what you're going to do is you're going to plug in 2 right here and 2 right here. Now make sure you use your parentheses just in case. So I'm going to use brackets, parentheses, 2 squared. You can never have too many brackets in your life, I'm telling you. Okay, and then minus, because that's my formula right here, minus, and then minus on the bottom. Brackets, f of 1. What am I going to do? I'm going to plug in 1 in that formula. So just 1 squared again. Okay, and then 2 minus 1 is just 1. What's 2 squared? 4. What's 1 squared? 1. Divided by 1. So this is just 3. 3 all over 1. Perfect. Let's go to the last one. The last one right here. I'm going to go a little bit faster. Okay, so what this is saying is f of x of 2, so that's 0, minus, and then f of negative 2, all over 0 minus a negative 2. So here's the difference. So this is already a built-in negative, right? Yeah, so since it already has a built-in negative, that's my built-in negative. This negative 2 came from my x sub 1. So I need to make sure I include that. What is f of 0? F of 0 is just straight up 0. So I'm going to skip that step because 0 squared, so it's really just 0 squared. And minus f of negative 2. Now watch what I do here. I'm going to put it in parentheses, and this is brackets and then parentheses. This is really negative 2 and then squared. Now notice how I'm using parentheses around the squared, because remember, negative 2 squared like this is negative 4, but negative 2 quantity squared is 4. I want negative 2 quantity squared. I don't want this. I want that. So I need to make sure I use my parentheses, even in the bracket. So, and then of course it's all over. This is going to become positive, so it's all over 2. So I have a negative, and then this right here, this little chunk inside my brackets becomes positive 4, but the negative is still chilling. And this is 2, and this becomes negative 2. One second. Negative 2. What is my average rate of change? Negative 2. Now, we flew through that. What I'm going to now do is I'm going to show you what it looks like when I actually put it on a graph. What do we just do? Like what are we actually doing? I'm going to show you what average rate of change looks like on the graph. And I'm not expecting you guys to write down the whole graph when I'm showing. I'm actually going to show you 3 graphs, boom, 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 boom. And then after that, it's really just Algebra 1 review. And I'm going to fly through that Algebra 1 review, okay? So I'm really spending a lot of time on this Algebra 2 review, or Algebra 2 stuff, because this is the new stuff. But after the next slide, I'm going to fly through all the other Algebra 1 stuff. And it's not really Algebra 1 review. It's mainly just taking what we've learned right here and using the importance of functions in order to graph certain other functions. Okay, so let's erase. Let's see what this looks like graphically. This is what it looks like graphically, and you're like, what the junk? And like, hold on. This first one corresponds to A in the last slide. This one corresponds to B in the last slide, and this one corresponds to C in the last slide. So our slope, okay, what we said was our slope in the first one, okay, we said our slope was 1. We said our slope was 1, right? Now watch, since our slope is 1, that's what we said, this is what we got. We got 2 separate points. How did I get these answers? Because these are the y values that you evaluated. These are the y values that you evaluated in the formula. Because what you did was you took f of 1 and then minus f of what? 0? Well, what is f of 1? When I take this formula, what was f of 1? Well, it's 1. And what was f of 0? Well, f of 0 is 0, right? Okay. What's 1 minus 0 when we square it? You know, we square both ones, we put in the formula. It's just 1, all right? So, but notice this. This 1 corresponds to this 1. This 0 corresponds to this 0. They are y values. You were skipping that step of evaluating for your y values. You found your y values inside of the formula, okay, at the same time. Instead of just being given to you the y values and the x values like Algebra 1, in Algebra 2, they expected you to not only find the y values just by giving you x values, but you found the y values inside of a formula that helps you solve the slope. And notice, watch this, guys. Notice the slope. If I go up 1 over, or up 1, and then over 2, so this is up 2 over 2, that's 2 all over 2, which means our slope is 1, which is exactly what we got here, okay? So even this secant line, what did we find? We found that this secant line was our slope. So when we find average rate of change, guys, what we're finding is the slope of the secant line. When we find average rate of change, we are finding the slope of the secant. Again, what is the secant line? The line that intersects. The line that intersects right here. That intersects our function. Now, if you're wondering, why the junk do I have a parabola here? What function did you use? You used x squared, right? This is your parabola for x squared. Right? Right. And so that is what we call my secant line. And again, the slope of my secant line is 1. Okay? The next one, this corresponded to B. We found our slope to be 3. And again, this should work. Watch. Looking at my 2 points. 1, 2, 3, 4, 5, 6 all over 2. So 6 all over 2 gives me 3. So what we did was we found the slope of our secant line. That's the purpose, all right? That's the purpose. And then how did I get 1 and 4? Well, if you notice, that 4, we had 4 minus 1 in our average rate of change, 4 minus 1 all over 2 minus 1. That's what we did. That's where the 4 came from. That's where the 1 came from. And if you're wondering, where's the negative, Mr. Carlson? There's no negative in these. Yeah, you're right, because the negative came from the formula. Remember, we had a formula with a built-in negative. Okay? Yeah, I'm just going to continue. This negative is built into my formula, and this was, x1. So that formula has a built-in negative, and that's where that negative gets it from. This 4 is your evaluation for your first point. This 1 is the evaluation, the y value, the output of the second point. And then see, our slope was actually -2, and we can actually calculate the slope. So up to all over 1, or -1. So this is like 2 all over -1, which reduces down to -2, which is our point, our slope. Okay. So I hope it kind of makes sense. I hope it kind of puts it together with the graphing and everything. You're not gonna really graph this stuff, so don't feel like you need to graph this stuff. But what you will be doing is average rate of change. You will be graphing linear lines, which is what I'm going to get to right now. I'm going to show you some helpful tips on linear lines and actually some review, some more review for Algebra 1. Now, if you don't remember this from Algebra 1, that's fine. By all means, just take the notes anyways. You can write a linear equation in two separate ways. You can write it in the point slope form equation, or you can write it in slope intercept form of the equation. As a brief review, let's just say I have 2 points. Let's just say I have 4, -5, and then let's just say I have 6, 3. How do I use these? Okay. Well, first of all, I would need to find the slope of these lines. So if I find a slope here, this is going to be 3 minus a -5, and then all over 6 minus a 4. So this becomes 8 all over 2, which equals 4. Okay, so my slope right here is 4. Now, I can use this form. That's my first step. My second step is I can use this form right here and just pick a point, and given a slope right here, I can solve the line like this. I don't need to solve it and put it in this form. So what does that mean? This means let's just use this point right here. So that means I have y minus my y1, which is 3, because I picked that random point. Doesn't matter which point I pick? No, it doesn't. I can pick this point. Y minus 3 equals, and then my slope, which is 4, and then x minus 6. And I can simplify this out and so forth, right? I can simplify that out and so forth, and this becomes y minus 3 equals 4x, and then minus 24, and then I can add the 3 over. And this becomes y equals 4x. Add the 3 over is minus 21. Okay? I can do that, right? Now, what if I did it this way? Let's just say I'm given these 2 points, and I found my slope to be 4. But I need to find my b value. What if I don't want to? My b value here is -21. But what if I want to find my b value? What you could do is take the same point and just plug it in here. So my y is 3, my x is 6. So this is 3 equals my slope 4 times my x, which is 6, plus b. So this is 24, and this is 3. And so this becomes -21 equals b. And then now I can plug it together, y equals 4x minus 21. Notice how you still get the same thing. This one, point slope form, is probably my favorite. If you remember in the first day or second day's video, I said something along these lines. Okay, but this is just review. This is for Algebra 1 technically. I hope you learned this in Algebra 1. If not, that's okay. You don't really need to know it too bad. But just know the difference between what we call point slope form and slope intercept form. Okay, point slope form and slope intercept form. Now, what we're going to be doing here is graphing linear equations, obviously, but we're going to be doing it and graphing it differently. So given the slope and the y-intercept, graph the linear equation. So given the slope and the y-intercept, what we want to do is graph the linear equation. Okay? So I already know that the slope right here is 2, and my y-intercept is 8. Okay? Now watch this. Remember, I know it's 8 not because of Algebra 1, but because if I said x equals 0 and then I solved for y, if I said x equals 0 and solve for y, this is still review, what I get then is y equals 2 times 0, if I plug into my formula, and then plus 8, which then I get 8. So what did I plug in? I plugged in 0. What did I get out? I got out 8. Remember functions last week, input, output? So this is how I know it's 0, 8. This is how I know it's this actual, like, this is my actual y-intercept. It's not just because this is my b, and yeah, the reason why it's your b is because of this. Okay, it's not because you just randomly call it, that's my y-intercept, and I don't have anything else to call it that. It's because this reason, okay? I plugged 0 in, x, my input, in, I plugged it in, I got out my y, my output, I got out 8, okay? So 0x, input, got out 8y, my output, okay? So that is how we kind of start. That's why that is the way it is. Now, of course, we graph just using my regular slope. I go up all over 1 to be there because my slope is 2 all over 1. Now let's just graph this baby. Whoa. That was intense. Okay. Of course, it looks something like this. Looks like it goes straight through. Oh, that's unfortunate. I can't go down anymore. Let's just call it good right there. That's my line. All right. So now, oh my gosh. I'm having technical difficulties here. All right. Now, use the intercepts to graph the equation. Now, here's why the reason why I want to go through this, because Math Excel. How do I solve this using the intercepts of the equation? I'm going to show you. Okay, just solving using the intercepts. First of all, in order to solve for just my x-intercept, just to solve for my x-intercept, I plug in 0 for y, okay, 0 for y, and then I solve for x, okay? So if I want to find my x-intercepts, I plug in 0 for y, and I solve for x. If I want to find my x-intercept, because that's what I want to use, just use the x-intercepts. So I have 0 for y, solve for x. So if I plug in 0 right here, that will give me 5 times x, and then negative 4 times 0 is just 0, right? So that means it's just, and then I can move the 20 over, and so it's just 5x equals 20. That's really what it is. Divide by 5 each, so I have x equals 4. What does that mean? Well, that means that's my input, which means what was my output? My output was 0, because that's what I had for y. My input, my x, was 4. So 0, 4, 0. So I'm going to do 4 right here, 0. So I'm going to plug a point right here. Math Excel will want you to plug these intercepts just using the x-intercept and y-intercept. So what about my y-intercepts? Well, I already kind of told you right here. I do x equals 0, or 0 in for x, and then I want to solve for y. So what does that look like? I'm going to solve for y. That looks like if I plug in 0 for x right here, that means I'm left with negative 4y and then equals 20 if I subtract or if I add the 20 over. Then divide by negative 4, of course, become negative 5. So that means my input was 0 and my output was negative 5. Okay? So that means we're going to go and plot that. So 0, negative 5 right here. And of course, we can get a line. Maybe. Ooh, that's not bad. Not bad. Okay. And that's what it would look like. Okay? Awesome. So that's how you graph linear equations the normal way. Like, this is the algebra 1 way, and this is kind of the algebra 2 way, where we can just use our intercepts. Yes, Math Excel will want you to just graph using the intercepts. So let me erase here. And let's solve just using vertical lines. Let's solve just using vertical lines, okay? How do I solve this using a vertical line? Well, it's rather simple. It's just solve it like normal. So this is 2y and then minus 4, so y equals negative 2. What does that mean? Y equals negative 2 means it crosses the y-axis. Crosses the y-axis. Okay, it doesn't cross the x-axis, crosses the y-axis at negative 2. Right there. Okay? That one should be pretty much review. This one, same thing. I just solve. So this means I have, if I add the 9 over, I get 15. This is 3x, so x equals 5. So that means I cross the x-axis. So I cross the x-axis. Not that my line will be horizontal. I cross the x-axis at 5. So 5 is right here, and I cross it right there. Awesome. Okay? And of course, you can plug this into Desmos, and Desmos will give the exact same thing to you. All right, which is fantastic. Let's move on to our very, very last slide, and then we'll get out of here. How do I graph absolute value functions? Now, absolutely, you can plug this stuff into Desmos. I mean, absolutely. But it's very intuitive if I teach it correctly because it's so simple. So simple. You're going to learn a couple things. First of all, you're going to learn a vertical shift. Well, first of all, what does it mean to have a parent graph? A parent graph is really where all absolute value functions come from. Your parent graph for quadratics is y equals x squared. Your parent graph for linear functions is y equals x. Okay? So if I had y equals x squared, it would look something like this, roughly. Just roughly. Okay? Right? If I had y equals x, it would look something like this. Again, roughly. Technically goes through that point, the origin. Now, if I have something like this, y equals absolute value of x, okay, the absolute value of x, I'm going to kind of box this so it keeps it with that color. It looks something like this. And so what the difference is it looks like a V. Okay, so it's like a V, and it still hits the origin. That's my parent graph. Now, let's just say, this is where all the other absolute value graphs come from. Let's just say I want to vertically shift it. What does that mean? If I want to vertically shift it, it's going to look like this. It's going to have like a +3 on top, which means I'm just going to move this point 1, 2, 3 points above. That's what it means. So it's going to look something like this. Roughly. Okay? Doesn't need to look perfect. If I say I want to do a horizontal shift, it's going to look something like this. Now, most of you would think, if you're given this, you'll think, oh, okay, so it's going to move left too, right? I get it. Actually, no. It's not going to move left too. This is actually a built-in negative here. It's what we call a built-in negative sign, which means what this is saying actually is a negative positive 2. So negative positive 2. So we're going to take that value, and that positive 2 tells you to move to the right. So if this told you to move up, okay, up 3. This says right 2. So I'm going to take my parent graph, move it 1, 2, right 2, and I'm going to move it right there. And that is going to be my graph. Oof, not really straight lines. Okay, let's look at something like a vertical stretch or shrink. So 1/2, what does a 1/2 look like? 1/2 is actually going to make it very, very stretchy. I'll do this in pink here. Okay, so 1/2 is going to make it really, really like stretched out. All right, so it's going to still stay here, but it's going to be like this. It's going to be really like fat. Now, if I said that was going to be 3 instead, it would be really, really skinny. And you don't need to know too much about that because we do have Desmos. Okay, I'll put a smiley face. I'm not gonna grade you too much on that, but again, like I said, we will use Desmos. And the last thing is a reflection. What does a reflection look like? I'm gonna use sky blue here. A reflection, if I have like a negative out front, what that means is actually just gonna flip my original parent graph. So it's gonna look something like this. Again, my original parent graph is in blue up top, and so it's just gonna flip it down. You can test all this using Desmos, and I encourage you to use Desmos.com to kind of test everything. But however, you're not really going to be graded on whether or not you can graph this. You will have some questions on Math Excel in which you'll have to graph. But again, just to double check, you can use Desmos and put it all together into one. This is the basics of transformations. In Algebra 2.2, we actually get into a lot more transformations. Same thing in the quadratic unit for Unit 3 for 2.1 here. In Algebra 2.1, we're going to get more into the transformations of those units. But honestly, guys, it's just that basic. And so if you thought this lesson was a lot of review and the hardest was like the rate of change, then great, awesome. Think like that, because that's what I want you guys to be thinking. What did you learn? You learned Algebra 2.1's rate of change, and that was the same thing as slope. You learned how to recognize common functions like linear graphs, absolute value graphs, and we kind of dabbled a little bit with the parabola graph. And then we use basic transformations in order to graph a function, namely absolute values. Okay? So homework quiz tomorrow. Remember, if you have an A or above, you do not need to take the homework quiz, but be prepared anyways. Your homework is going to be on Math Excel, of course, graphing functions. If you have any questions at all, please email me. Like, subscribe. This is C Squared Mathematics. I'm Mr. Carlson. See you guys later.